All right, so 2 and 1. Let's go. So radicals, roots, and fractional exponents. So what I want to do in this video is to tie in your radicals and tie them into exponents, and exponents that are actually fractions. So I'll show you through a few examples of how that is done and that they're actually equivalent, right? So there's kind of two different ways of representing exactly the same thing. So if you've missed the introduction on roots and radicals, I'll put up a link up above so you can check that out before you watch this video, because I will assume that you know what a radical is now, okay, and what it does. So in this case, you see three examples. You see the square root of 4, you see the third root of 8, and then the fourth root of 16. So it turns out that this wonderful radical that we use quite often, actually, so this right here, so this symbol, okay, that we have, can be written as a fraction. Now, for the square root, so let's not forget, so there's a 2 outside here, which we don't typically write. But what this is saying is that this radical symbol can be represented as a fraction in the following way. So the radicand stays the same, so the 4 is just a 4. And then instead of doing a radical symbol, you can literally change that radical into a fraction by saying the following. The fraction now has a numerator of 1 and a denominator of your root. So whatever your root is, so this is the second root, so it's the square root, okay, so it will go in the denominator. And 4 to the exponent of a half is exactly the same thing as the square root of 4. Now you can check that for yourself, all right? So if you check and take your calculator, for instance, so you take 4 to the exponent, and this is, now the exponent is a fraction, so it's 1 over 2, equals, notice that it's 2. And again, square root of 4 obviously is 2 for us. So these things are equivalent. So the symbol of radicals and then of fractional exponents is the same. Now the key thing is that our numerator is going to be equal to 1. And then our denominator is simply whatever root we have that we're taking. So for the second example, so if you take 8, now my root is basically the third root, all right, of 8. So what that would mean is that this is going to be 1 over 3. So that 3 again comes in the denominator. Now the following example, you probably are slowly starting to catch on, is going to be 1 over 4. So it's pretty neat to be able to tie in these radicals to actually just exponents, because we know exponent laws quite well, right? So we utilize them quite a bit, but most of the time they're just introduced as just simply integer exponents. But all of those rules apply to fractional exponents as well. Now, if you've forgotten about exponents and the rules, I'll put up a link, okay, up above, because you might need it for some of the stuff that I'll present. So here, that is how we would begin, all right? So this introduction to tying in radicals with actual exponents. But you've noticed that in all of these cases, when you have the nth root of something, all right, you have basically your numerator is equal to 1. But that's not necessarily always true, right? So you don't have to have the numerator always equal to 1. But then what would that mean, right, if you wanted to tie it back into radicals? Okay, so if the numerator is not 1. So here's an example. So for instance, if I gave you now an example of, so I'm going to change this up a little bit. So I have 8, and now I'm going to say 2 over 3. So now you would say, well, you have a 2 in the numerator. It's not a 1. If it was just 1 over 3, I would know that this is just the third root of 8, which would have been equal to 2 as an answer. But what is this equal to? So don't forget that with your exponent rules, okay, you can rewrite this as two things. I'm going to write it in one way. So for example, you can write it like this. Okay, so 8 to the power of 2, which we know, so this is 8 squared. And then we're taking the third root of basically 8 squared. So this right here, all it means is you have 8 in, as the radicand, it is squared. So notice this is your 2, that's your 2, and then your 3, okay, becomes your 3, and here is your radical symbol. So that's what this would mean. So you can get your answer to this and find out exactly what that is. Now, the reason why we broke this up, so notice I put a square here and then I put a 1/3 here, and that is just from exponent rules, because 2 multiplied by 1/3 is just 2/3, which is exactly what we started with. So that's what I used. Now, you can just as easily, instead of writing it like this, you could have said this is 8, 1/3, and you could have put the squared outside of the bracket. Because again, if you have 1/3 times 2, it's still going to give you 2/3. And this, if you would write it out, would have been simply, so this is the third root of 8, and the whole thing would have been squared. So all of these are equal. So it's pretty crazy. You see 5 things here, right, that are all equivalent to each other. And radicals themselves are just simply fractional exponents. Now I can find out exactly what the answer to this is, or to this for that matter. It doesn't really matter. So my answer, so the third root of 8 is 2. And notice that 2 squared is equal to 4. On the other side, you can first do, so you would actually find out what 8 squared is. Well, 8 squared is 64. So that would have been 64 under the radical symbol. And now you're going to take the third root of 64, which is equal to 4. So both of these would give you exactly the same answer. All right, so now I want to just give you, so in general, so you saw it by example. Now with these fractional exponents, you know, how you would actually change it back to a radical. So in general, if you have some number, so let's say we have some number x, and it is being raised, okay, so let's say your numerator over your denominator, so a over b, so let's say in this case. So these, if you want to transfer these into a radical, okay, then it would look something like this. It will either be, okay, so notice this is the b root, okay, of x, and then, okay, so your a is going to be outside of your brackets. So that's one way of doing it, okay, or okay, it also can mean that you have, this would have been x to the a, and then take the whole thing and take the b root of it. All right, so again, so if it was some number, so if it was 16 and let's say 3/4, then you can write it as, so either, so 4th root of 16 raised to the power of 3, or you can say this is the 4th root of 16 to the 3. All right, and both of them give you exactly the same answer. And you can see which one is easier to work with. All right, so just by looking, for example, at this, all right, so in my opinion, it's probably this one that's easier to work with, because the 4th root of 16 is 2, and then 2 to the power of 3, all right, so you can get that it's 8, okay, and then if looking on the left-hand side, that would have been a little bit harder to do, all right. Okay, so that's all that I have for you, okay, with these fractional exponents. I hope that you found it useful. We'll see you in a future video. Bye, everybody.